In a serious accident in the construction industry, the thick steel cable of a towering crane suddenly broke while lifting large, heavy objects hanging from the crane, falling straight to the ground below. Cancel all construction efforts of the ongoing project. Another incident also involved a crane's steel cable breaking while unloading goods at the seaport. The machine fell with such force that it was thrown into many pieces. The accidents, which were caused by serious failures in crane equipment, have highlighted the inherent risks of operating heavy machinery and prompted assurances that strict safety measures would be taken to prevent such disasters in the future. These are cases of accidents caused by overloading goods. On steep forested roads, the challenge of navigating steep terrain is often exacerbated by the presence of heavy trucks and overloaded tractors. These formidable machines are designed to transport large loads such as lumber, tank trucks, and raw materials trucks. Tractors are overloaded, exceeding their permissible capacity, and are especially vulnerable when climbing hills. Too much weight not only puts strain on the engine, but also affects the structural integrity of the tractor itself, as axles groan and the chassis flexes under extreme pressure. The wheels, lacking traction, often spin uselessly against the resistance of the slope. This struggle not only hinders progress, but also poses serious safety risks, potentially leading to uncontrolled retreat and, in extreme cases, subversion. Heavy trucks, while built for durability and strength, encounter steep uphill grades that often cause them to stall or overheat, which can cause brake failure during the downhill process, leading to accidents. Uncontrollable accident. To avoid these accidents, strict compliance with load regulations is mandatory, enforcement of weight restrictions and load limits. Preventing dangerous overloading is not only dangerous machinery but also endangers the safety of those navigating these formidable inclines. We are sharing experiences related to the use of Tatra vehicles in road construction. It addresses the challenges faced on unpaved roads, also known as dirt roads. The video highlights the difficulties of making roads without the right equipment, and mentions Tatra's ability to handle terrain well, thanks to features such as load carrying capacity high when empty, and the wheel axle locking system is very effective. However, it contrasts this with the Ural, which acknowledges its overall reliability, but notes that it is prone to getting stuck in deep ruts due to its inability to handle crossover situations. Overall, it provides insight into the practical challenges faced during road construction. The tracked military tank, known for its robust design and off-road capabilities, encountered operational obstacles when traversing challenging terrain characterized by soft, flooded soil. The tank's continuous track system, optimized for traction on a variety of terrain, was affected by sticky and saturated soil covering the tracks, resulting in loss of mobility. The tank's engine, exerting tremendous power, was subjected to the resistance of the bogged environment, but the sticky nature of the mud hindered the rotation of the tracks. Attempts to use differential steering and engine power to escape the tank proved ineffective, as the suction effect of the increasing mud amplified the stationary force on the track system. The stone excavator at the marble quarry could not keep its balance when moving a block of marble that was too large, much larger than the allowable load. The stone slab pressed on the bucket of the truck, causing the vehicle to be unable to move and lose its balance, lifting itself up high. The stuck truck experienced a standstill while operating in suboptimal weather conditions, especially in snow-covered and difficult slope environments. The traction control system, calibrated for optimal performance under normal circumstances, was unable to counteract the adverse effects of reduced friction on the wheels, rendering the vehicle unable to move. The onboard torque distribution mechanism tried to optimize the transmission of power to the wheels, but the high friction coefficient of the snow hindered forward movement. To rescue this truck, another truck is needed to combine the cable system connecting the two vehicles. Then the rescue truck starts moving forward to pull the stuck vehicle forward. Through the coordinated efforts of both trucks, the stuck vehicle was successfully extricated from its difficult. In the dynamic field of heavy vehicle operation in the work environment, many types of accidents manifest themselves, each associated with a complex interaction of mechanical, operational, and environmental variables. School. This is one of the accidents. Collisions, both with stationary objects and other moving objects, are widespread hazards affected by limited visibility, the inherent blind spots of large vehicles, and the urgent need for navigation in confined spaces. Rollover incidents, a frequent concern, often stem from factors such as suboptimal load distribution, uneven terrain, and sudden steering maneuvers, underscoring the complex balance required when operating heavy vehicles. Equipment failures, including malfunctions in braking systems or tire blowouts, constitute serious threats that require meticulous attention to routine maintenance, proactive system testing, and deployment of innovative technologies. Predictive maintenance. Furthermore, the loading and unloading phases present many distinct risks, with incidents involving collisions with objects or personnel in the vicinity, arising from misjudgment, loss of contact, or equipment malfunction. The complexity of heavy vehicle operations requires a strong focus on procedural compliance, site-specific risk assessment, and integration of proximity detection and collision avoidance systems, to minimize these potential dangers. Addressing these challenges requires a multifaceted approach, integrating advanced safety technologies, comprehensive driver training programs, and strict adherence to standardized operating procedures. Incorporating telematics systems facilitates real-time monitoring of vehicle performance, assisting in identifying potential problems in advance. Continuous improvement initiatives, informed by post-accident analyses and near-miss reports, contribute to building a culture of proactive risk mitigation. In this ever-evolving landscape, a comprehensive commitment to safety procedures and technological advancements is required to enhance the resilience and accident recovery capabilities of participating heavy-duty vehicles into diverse working environments.